Okay, let's okay, we talked last week about the basics of encryption and how SSL evolved and its various features. Okay? So, what we need to do today is set this up for communications on our web server and our mail host. Okay? We haven't done anything with configuring the LDAP server, but you can, and I'll leave that for you to pursue if you like, in the context of the assignment for this class. Okay? But we do need to set it up for accessing the mailbox and for passing the mail between the Windows host, between our web server and the gateway and the mail server. Okay? As I said, and I think just to say again, Postfix knows how to use SSL, so we could go into the Postfix documentation and configuration files and set it up. And indeed, if you look in there, you can see that the directions are, the configuration files are partially prepared for that. Same thing with Dovecot. Dovecot understands how to do SSL. Monkey web server is too simple, okay, but any kind of civilized web server like Lite, HTTPD, or Apache, you could configure that one as well. But it means working with different sets of documentation, debugging different configurations, okay? And it's much simpler to do what we do, which is to do a minor reconfiguration of our servers and then have a single utility that stands in the middle that we call S-tunnel. Okay, so basically what's going to happen is S-tunnel is going to intercept all the communications. Actually, S-tunnel is going to work exactly like what we call a man-in-the-middle. We're going to talk about man-in-the-middle attacks and how that can be used for diverting traffic without the source and destination knowing it. S-tunnel does exactly that. It diverts the traffic without anybody knowing it, but we use it for a benign purpose, which is to secure our communications across the network. And again, one thing I want to just stress before we go any farther here is that SSL only provides security for the data while it is in transit, as it's going across the network. Okay? So if somebody captures it, they can capture it still, but they would have to find a way to unencrypt it to read the message. If we're talking about securing our database of customer information, if we're talking about keeping our latest designs or blueprints or our financial information or our HR information, all of that has to be done separately take separate security measures because this SSL is only about the data in transit. So, with that caveat, okay, we scroll down here and, okay, we've got an explanation of S-tunnel. And again, S-tunnel takes in every packet it receives and encapsulates it in a SSH and an encrypted SSH packet, okay? Now again, SSH in the stack fits between the application and TCP. So S-tunnel catches it before it goes to TCP and gets broken into packets and then passed down to IP. And on the receiving side, once TCP has collected all of the relevant segments and it's ready to pass it up to the application, SSL intercepts it and unencrypts it and then passes it up to the application. Okay, and just again, this has two names because SSL was invented and popularized by Netscape, the people that we now know make our Firefox browser, okay? They turned it over to the IETF, who renamed it to TLS, okay? And you may see one name or the other in the documentation. So we talked about these concepts, okay? The certificate authority and the idea that we can't have all digital signatures looking exactly the same because that opens us up to a man-in-the-middle attack, okay? So we have digital certificates that are signed either by a certificate authority or we can create a self-signed certificate, which is not as trustworthy, but still works in the majority of cases, okay? Client and server certificates, we'll talk about that in a minute, okay? In the certificate file, we'll take a look at that. And here's the diagram, okay? The essential dialogue for the SSL protocol. And again, we just need to understand that this is what goes on in the background. Okay? Again, if you're interested in replacing the Monkey web server with Apache or the Light HTTPD, okay? If you think that's an interesting thing, that you think that would help as you move on in your career, by all means, put it to your group, write it up as or give me a little explanation of what you want to do and why, and I'll be happy to put a point value on it for the assignment, okay? Because we've got a lot of flexibility on the assignment for you to pursue tasks or projects that you are interested in. And these are a couple of good references for setting up Apache separately. And again, you can set up Apache, Dovecot, Postfix, and OpenLDAP. You can set those all up to work separately with their SSL TLS. And that would be definitely a 20-point project if you wanted to do it. But we're going to take the easy way out, okay? And we're going to use one one utility here, one configuration, so that the configuration is very similar on all of our servers. There's just a few minor changes from one to another. Okay, so the last concept that we want to talk about here is port forwarding, okay? And the first thing we need to do is figure out which ports we want to use. We could, okay, the well-known ports are the ones for the standard protocols assigned by the IETF 0 through 1023. We're best off sticking with those standard ports, okay? Because people are going to assume that we are using them. That's why they are standardized, okay? And we could cause ourselves some other kinds of weird complications, especially if we don't remember what our port scheme is, okay? If we don't stick with the standard ones. So we stick with the standard ports for the standard protocols, well-known ports. If you have a networked application, you can go to the IETF and they'll assign you a port in this range. And then this range here, 49152, don't ask me how they picked that number, but they did, through 65535 are never assigned to anything. We're free to pick random ports in that range, and we will find some applications that do that, but we're not going to go into that process in the class here, okay? But these are the important ones, and as you can see, oops, there's a HTTP port. The standard one is 80. And then for HTTP encapsulated in an SSL packet, okay, the standard port is 443. Same thing for IMAP and normal IMAP and encapsulated IMAP, LDAP and LDAPS, SMTP, SMTPS, okay? The submission is a plain text port, so if we're using the submission port and then we encrypt it, we would send it in over the SMTPS port. Telnet, there's no counterpart for Telnet, so we have to figure out something for that for ourselves. TFTP, again, they don't have any standard port for encrypted TFTP. NetBIOS and DS, okay, these are for Microsoft interfaces and for setting up Windows shares, okay? And again, we could encrypt this traffic using S-Tunnel exactly the same way we do. And then there's a few others down here which are just perhaps ports of interest, okay? You might come back to this later when we're talking about security and IP tables and setting up packet filtering rules to create a firewall. But for now, we're only interested in these ports here, web, mail, mailbox, IMAP, mail delivery, SMTP, and LDAP. Oops, hang on a minute. Okay, so the way this works, okay, we set up each service separately in the S-Tunnel configuration file. So on the web server, we'll accept LDAP on 389, which is the normal plain text LDAP port. S-Tunnel will do its magic and then send that on to the LDAP host on port 636. S-Tunnel on port 6 is going to be listening on port 636 there, okay? It's going to accept those packets in and do its magic and then pass them up to the application on port 389, where it's normally going to be listening. Okay, so the normal plain text communication would be 389 to 389. Okay, we intercept that man in the middle and move it across a different port with our two ends of this connection, and then just pass it up to the application. Okay, same thing for the web server, and we want to access the mailbox. On the mail host, we'll have S-tunnel listening on the secure encrypted port, okay? And we have squirrel mail sending things out, accepting things back on 143, and dovecot over here on 143. Same thing here, okay? We take it in, postfix is, squirrel mail is going to be pushing it out on port 587. We grab it, send it across to the gateway, and pass it up on 587. Okay, so these guys here, these servers, these applications, don't know that this has ever been encrypted. They don't really care, okay, because they're getting the plain text stuff on the port where they need it. So, what we need to do is set up S-tunnel, and we need to make some little configuration changes to fine-tune the initial configuration files that we have already. I've got my 3 virtual machines running here. I'm going to start with the web server. Doesn't really matter which one we start with. Okay, I'm going to run through the wait. Hey, what happened? Oh, I know. I need my magnifier here. That's the one. Okay, I'm going to run through this usual routine here. I'll run through it again just so that we can, oops, got the wrong one here. There we go. Run through this, and so I log in, password, username, ROOT, password, TOOR. Okay. First thing I'm going to do is check to see if my IP is direct, see if my IP got configured right. Only on the TinyNet machines is my minus IP. Okay. I'm on 56, and that's net A, so that's good. Move over to Alt F2, log in, TOOR, and this is my file manager page, and C, and I move over to F3, and this is my process page. Right? Get that set up, and you've got your dashboard ready. You're ready to configure. Let's just go through that one more time here while we're doing it. Let's do it on all 3 machines. My IP, netc 76, all good. HTOP. This is my mail server, so I should see postfix, and I should see vmail, and I should see dovecot, all good there. So last one, I'll just do it on the gateway so I don't have to slow down and do it again. I'm going to skip the my IP step here. Though I'm going to do one thing though. I'm going to do my Flower from Holland routine. Net stat minus TULP, my tulip. Okay. That looks good enough, okay? And let me, oh, here we go, Alt F2, File Manager, and Alt F3, processes. I can see DNS mask with nobody and postfix, so all good. Okay, so that's all right. Now, just back up here. Okay, so here's my web server. So let's look at the external configuration files. I say, let's look at the external configuration files. What immediately should we be thinking? Where are we going to find them? etc, right? That's where we would expect to find them anyway. It's our first instinct. And where might we find them? Oh, how about in etc S-tunnel? How nice of that. Okay, so we got a few files in here. Okay, this is the one, this is explained on the website. The generate key shell script, as you can see, it's got the star, it's in green, so this is an executable file. It looks a little bit cryptic, but we'll talk more about this kind of syntax for bash shell scripting in a couple of weeks' time after we get back from the semester break. Okay, just to point out that it's there. This PEM is the certificate file. This is the one that holds all of the hashes. Okay, I can look at this one with F3, and it's actually pretty much plain text. Okay, but look at the top there. It says this is your private key. Okay, and you look at it, and it's just a big string of letters, just a long set of letters. Okay, all blocked out very nicely. But when we look at it in letters like that, what is it really? Sorry? First of all, does what we're seeing up there look like it would translate into hexadecimal? Not really. Why?
Because it will contain like plus or the slash symbol, so I think it will be more like base 64.
Yeah, okay, good idea. Base 64, yeah? Okay, what we're looking at here is a ASCII representation of a very long bit string that the computer actually sees as one very remarkably huge number. Okay? It's just a representation of a bit string. So, in this PEM file is our private key, and then there is the certificate. Okay? And certificate is a bit bigger, okay, but still it's in exactly the same format. Okay? And all it is one huge, okay, this is a message digest. It is one impossibly huge number that the computer is very happy to process. And inside the certificate, what have we got? We have the public key of the person. We have the name of the person, who it is. Okay, a little bit of identifying information. We have the name of the signer. We have the signer's public key, okay? And this message digest was used, I'm sorry, this message digest was created how?
Encrypted with private key.
With the signer's private key, correct, okay? So we can take the signer's public key out, and we can get the signer's public key, and we can run whatever data we have through this hash algorithm, again, the same algorithm, come out with the outcome and compare that outcome with what we have here as the certificate. Okay. Now, one thing here, it's important note, okay? Just gonna leave this maybe I can tone this down a little bit so that it looks reasonable in the magnifier here. Okay, let's make it a little bit bigger. Okay, let's back up and just take note of something here, okay? So, the certificate and key is needed in the server mode and optional in the client mode, okay? We put the private key and the certificate in one file, so that cuts down a little bit on the configuration, okay? And so we'll see this in the configuration file, but here's the one. The file SSL PEM is your private data, your private key, and your certificate, okay? So, SSL for SSL to start automatically, this file must be readable only by root or the system account that runs SSL. Okay, so that's the first thing, and we'll want to check that. Okay. Second one, very important. Postfix, Dovecot, everybody says, do not configure client certificates. Okay? And they cause problems in configurations that work well without them. It's a loser to configure client certificates. Don't do it. Okay? Don't do it. So the configuration file that was used to create the self-signed certificate is down at the end of the page here. Okay? Creating a chain of PKI certificates, or creating a PKI chain of certificates, setting yourself up as a certificate authority, and creating a root certificate, an intermediate certificate, and then finally the site certificate or the service certificate. Not too difficult. It's a, I think, 10-point activity or a 10-point project for the assignment if you're interested and you want to try it out. So, port forwarding, let's skip down here to the chase, okay? We check the configuration files. Let's take a look at the configuration files here on the web server. I have to do a couple of things on the web server to get it configured. Let me move back over here. Okay, so there's the PEM file, okay? We got some example files here, and again, this one that has the TXT extension is the one with extensive documentation about each of the directives. There are a couple of other samples here, okay? But the ones we are interested in are the www.client.conf and the server.conf, okay? Client conf, server conf that has to do with the port forwarding, right? So when it's acting as a client, it's going to take it in from the application and send it out toward the server side. When it's acting as a server, it's going to be taking it in on the secure port and passing it up on the plain text port. So let's just start with the client conf here. Let's F3 to view it. Now, note something about these configuration files, okay? They are using a semicolon as the marker for a comment, not a hashtag, okay? I don't know why that is. Nearly all the time it's going to be a hashtag, but for your standard DNS stuff and for S-Tunnel and for a few others, it is a semicolon. So, never mind, that's just the way it's going to work, okay? Set UID, nobody. Set GID, nobody. What do you suppose that is?
GID.
That's the way it's going to show up in HTOP. That's the user and the group that will own the process. It's a system account. Nobody can ever log in, but okay, it's owned, so it can own the files and things, and that is a layer of security using system account. Okay. Facility and level daemon dot notice will be used unless we specify it in syslog.conf. We haven't looked very closely at that so far. We'll come back to it and look at it again, but this is where we can configure that. Okay, we could send it to a different file, or we can just let it use the system-wide ones, and we will check that in etc syslog.conf. Performance tuning, let's skip over that. Okay. Yes, this is client mode. Okay. Now, for some really weird reason, lots of applications like to create a file, usually in var run, that just has their process ID inside. Now, I'm not quite sure why that is, but lots of people do it, and so we'll go along with it. Okay, we just need to make sure that var run has permissions like stroke temp, okay, so that anybody can write files to var run, but only the owner can delete them. I think we set those permissions some time back, okay? But what we're going to do here is just allow S-Tunnel to write its process ID, that number at the beginning here, write its process ID into a file in that directory. Okay? PEM file, always needed in server mode. Comment these for our client mode. They are appropriately commented. No client certificates. Okay? And here's the service configuration. Except on the host and the port. If we don't specify the host, it is this one. Okay? And so for our webmail client, we need a few services. Okay, we need LDAP for address book lookups, IMAP for accessing our mailbox, outgoing mail to the gateway. Okay, so here we've done accept 389. Oops, sorry. Stop moving like that. Okay. We accept on the plain text port from the AP application. We intercept it, do our magic, and push it out on 636. IMAP. Uh-oh. What's the problem with my IMAP directive? The problem that drove us crazy a couple of weeks ago. Let's not let it drive us crazy again. What's the connect? We accept on 143, fine, and then we connect. Oh, it's no mail admin, but it's close. It's mail host. Yeah, right. We need to fix that. Hang on a second. Let me get out of this and go into F4, into the editor, and run down there. There we go. Mail host. .tinynet.edu. Okay. And SMTP. Okay. We accept on 587 and shift it out across the standard encrypted port for mail. Okay, so let's save this one with F2 and close it up with F10. Take a look at the server side. Oops. Set UID, again, all of this part is going to be the same, so this is so easy, yeah? All we need to do is shuffle, okay? So client equals yes is commented out, that means this is the server one, okay? So we set the server PID, we've got our cert file there, which has both the private key and the certificate in it. Okay, HTTP, okay, this is when we're acting as an HTTP server. So we're expecting our browser to have already encrypted the information that it sends across, okay? That means we're gonna, that means we need to put in the URL with an HTTPS rather than just HTTP, okay? And so we'll accept on port 443 and connect. Ooh, what's the problem there?
In the HTTP and HTTPS port 80 and 80 is the
Yeah, the plain text one is supposed to be 80 and not 880. So, ouch, man. Who's the sloppy typer here? Anyway, never mind. Let's jump down to the end and fix that. Let's just double check it though before we fix it, just to make sure. How do I check that? How do I check which ports it should be?
That's
Yep, there we are.
TULP.
Mine is tulip. I'm gonna put an N on it so it gets me the port number. Okay, and true enough, we have to read it kind of backwards from the bottom up. Monkey is listening on port 80, right? SSHD on 22, and my DHCP client on port 68. Okay, so Monkey is on port 80. That means I'm fixing this correctly to say connect on 80 after I receive it in on 443, and do the S-tunnel magic. So, let's F2 that, save, and F10, and that's pretty much all we can do, except look at the sample file. Oh, actually, we need to do one more thing here according to our instructions. Okay, we just did these two parts. Step 4 we did, but we forgot step 3. For squirrel mail, change config server address.php to point at localhost rather than the other servers. So, where are we going to find this config server address.php?
What?
Sorry?
/1 folder.
Oh, good news, man. You're spot on. You're right on the ball today. Okay? We put all our PHP stuff in var, and we're in var. Var monkey, that's the old configuration space for the monkey web server. Okay?
/www.
Yeah, that's right. Var www, that's where we change the new document root to be, right? And the new script alias points here. So all of our PHP is going to be, look at that, squirrel mail, all nice. It's going to be down here in var and www. So we choose squirrel mail. Where should I look next? There's a configure script there. There's a readme. There's a index.php. But no config server address. Where do you suppose I can find it?
Config.
Let's take a guess. Config. Okay. Now again, a lot of these are too long for the display, but you can see it down at the bottom. ADDR is address. That's going to be addresses as well. Some defaults, headers, IMAP, config page, plugins, squirrel logger. Let's go here, squirrel logger. Oh, there it is. Config server. Wait a minute, where did it go? There it is. Config server address.php. Okay, you can see down at the bottom that's the same one. So I'm going to jump immediately in with F4, and I find that my MC editor, somebody has very helpfully colorized the directives, but very unhelpfully made the comments extremely hard to read. Okay? You can see the directives are very easy, but the red color there on the blue background doesn't have enough contrast for me to see very easily.
Sir.
Yeah.
Why yours is color? Well, some of us is gray word or white word.
Okay, did you use F3?
I press F4.
If F3 is, if it's F3, it's just look at it and it's all gonna be gray. If it's F4, it'll be colored like this.
Sir, I press F4.
And it's still gray?
Yeah.
Oh, I don't know.
It's okay. Let's carry on.
Yeah, never mind. Okay. I'm gonna use F3 here for the display, just so we can see what we're doing. Okay? So again, lots of comments in here. Set the default domain. Okay? Okay. Just a little thing to say here about PHP. Okay? What we're doing here is, this is a file that Squirrel Mail will read when it starts up. Okay? Now, these are C style comments that go from the /* to the //. Okay, so we can have a block code inside. These stars here are just for decoration. Okay. This string domain equals, this is a variable assignment in PHP. So somewhere this is going to have been declared a global variable, and all we're doing is giving it a value here. Okay, so it reads through this file to get values for the local variables. So this is the domain part of local email addresses. Okay. The next directive down here is your SMTP server. Okay. Usually the same, and the SMTP port number. Okay, and again, it shows here, this is the declaration somewhere in another file. Okay, and what we're doing here is we're assigning values to that address. Now, this is a C style comment. This is a C++ and Java style comment. Okay, PHP uses both. Okay, so it says here for stunnel, okay, this is the SMTP server address equals localhost, and the SMTP port 587. This one is commented out, and this one for initial testing is sending it to the gateway, and port 25 here is commented out. So all I need to do with this one is uncomment the localhost and comment out the gateway. Okay? That means that when Squirrel Mail sends the mail, it's going to send it through the localhost channel. stunnel is going to pick it up. stunnel is going to push it out to the gateway. The gateway is going to find it and will make a change on the other side there so that the gateway will receive it, okay, as it comes up from the localhost channel. Next one down is the IMAP one, okay, and again, for Squirrel Mail, we need to uncomment the two here, which is localhost and 143. Comment these out, okay, so that Squirrel Mail is going to pipe this down to stunnel on the localhost channel rather than sending it directly across to the LDAP server. So let's make those two changes. Ooh, ouch. Okay. I have to get into the editor here. Now I have to look very closely here. So I uncomment this one. So now it's localhost and 587. Comment this one out so that it's all in visible. Okay, localhost and 587 are the ones I want active, and down here, same thing. I want, oops, ouch. Localhost and 143. Didn't really need that extra 143 in there, did I? But never mind. We'll just do it like that, just because it's there. And the rest of the stuff is server type, what kind of mail we use, and that's pretty much it in this server config PHP file. So let's save that and exit. Okay. And oh, we don't have LDAP up and running. Let's get here. Okay. Postfix main.cf on the mail server. Change the relay host directive to point at the submission port. If you did not do this already as part of the SSL setup, we left the SSL setup for the assignment as an independent project. So this is all we need. That's all we need to do on the web server. Let's switch over to our mail host then. And there we go. Says, oops, what are we looking for here? etc postfix main.cf. All right, at least it's very handy with giving us the whole path there. etc postfix, etc postfix main.cf. We'll edit that one. Okay. And again, if we want to know what all of these are in detail are about, we look at the TXT part. Okay, my networks, relay domains. Here we go. It says here, relay host equals gateway.tinynet.edu. But which one is active?
The bottom one.
The bottom one. Okay, and the bottom one already has the host name. It's already using the submission port. So change the relay host directive to point at the submission port. We did that already for whatever reason. So that's all taken care of. So nothing to do here. Let's just take a quick check. Oops, that's my web server. Let's just quickly, while we're here, almost in the right space, let's just back out of this and back out of here. Take a quick look at the S-tunnel configuration. Okay, I've got a client.conf and a server.conf on this one as well. Use F3. Top part I know is all the same. That's why we're using S-tunnel. Okay. And this one, we need to use this. We need this so Dovecot can use LDAP for its login lookups. It's already set to, again, accept on 389 and push it out on the secure encrypted LDAP port. The server.conf, again, all the same at the top. That makes it so easy. Okay. We accept on the encrypted IMAP port and pass that up to Dovecot on port 143. So that's all good. Okay, now here's the question. That part, ready? Next step is make the startup file executable and find out if it will start automatically at boot time. Ooh. Okay, let's switch back to the web server. Let's do that one first on the web server. Okay, so I want S-tunnel to run automatically each time the computer starts up. What do I do? Where do I look? How can I tell?
Startup.
Sorry?
Small.
Remember, when we start up, there's a boot process that calls a bunch of scripts, right? It'll call one script, and that'll call another script, and that'll call another script to start each of the processes that we want, right? So where are those startup scripts?
etc.
Yep. Let's get all the way out of here. And etc, and then what?
RC.D.
rc.d. And so, what am I looking for here? How about an rc.s tunnel? There it is.
Smart.
Okay, got an rc.s tunnel. What do I need to do to get that running?
Smart.
There we go. chmod, right? So I need to change the permissions.
F9.
F9 and file and chmod and what?
Executable.
Set the execute bit. Watch that 644 on the other side. Changes to 7, 5. Oops, 5. There we go. So I set those bits. Okay. Now, how can I find out if it's prepared to run this one? Remember, we had this problem down here. Oh, look, I didn't set up my XONET-D on this one for some reason. We had this problem last time when we set up XONET-D, right? We said there's no, we looked in the files and we said, and to find the INET-D, to find the XONET-D, and we had to end up renaming this one. Let me just do this real quick. Oops, hang on a minute. File, chmod, let me make that one executable. Set, okay. Where did we look? Okay, again, just a quick review. The master one is rc.m, the M for multi-user mode, which is what's going to happen at a standard boot up. Okay? 2, this one is the one that's configuring the Ethernet interfaces. Okay? But there's 2 here. There's rc.inet1, rc.inet2, and there's this one, rc.local. Okay? Those are the 3 we're most interested in because inet1 actually we don't need to worry about inet1 because inet1 is just doing the Ethernet interfaces still. So it's going to be in inet2 or rc.local. So all I have to do is F3. Look, it's 4847 bytes. F3. Rather than scrolling through this and looking for it, what should I do? Yep, F7 and put in tunnel. Why not? Search string not found. Okay? So S tunnel is not going to start from here. XONET-D is not going to start from here. INET-D, yep, start the INET-D server. Okay, so I'm going to rename my XINET-D with what?
inet.d2.
F6, right? F6 is renmov, F6 is red mauve, rename or move. Okay, move file rc.exonetd to rc.inetd. There we go. And that popped up into its proper place. And look in rc.local. Hey, there it is. Start S-tunnel. If etc rc.d rc.s-tunnel is executable, then execute the commands in that file. Okay. And notice down there for monkey, look at that echo command there. We'll be looking at that as soon as we get back from semester break. We start talking about bash shell scripting and GCC and the compiler and pipes and filters. Pipes and redirection. Okay, so rc.s-tunnel is going to start for us. That's fine. Now, we need to, once we've got it set up, we need to test it. Okay, oops. There we go. There's my rc.s-tunnel. Now, again, if I just touch enter here, it will run it, but the MC screen will come back and replace the output so fast that I won't be able to get to see it. So what I'm going to do is I'm going to switch back to my Alt F1 here and just do what it said in the shell script. etc rc.d rc.s-tunnel. Oh! That doesn't look very good. Okay, what have I got up here? What's something that we recognize as a cause of failure?
No such file
No such file
or directory.
or directory. That should be an easily recognizable cause of failure, right? Okay, so if we work backwards from there, what file is it looking for? It's looking for etc s-tunnel stroke etc s-tunnel www.server.conf. That's probably no wonder it can't find it, because we know that we have an etc s-tunnel here, but we know there's never going to be this path. Okay, so it means that we need to go into the shell script and fix what's going on inside there. Okay, this is just the short help. Okay, but notice it's got starting s-tunnel with server.conf. Now it's got starting s-tunnel with client.conf, and the same damn thing happened here. Okay, no such file or directory, because this etc s-tunnel duplication came about somehow. So, let's fix it. Okay, so let's open rc.s-tunnel in the editor. F4. Oh, look, it's so nicely colored. Okay, we're going to again talk about the bash syntax and such in our next starting when we get back from the semester break. But just take a quick look at this. Okay. Here I've got a if then phi, right? Standard programming if statement, right? If the condition, okay, of string 1, whatever that means, is equals stop, then we kill all the S tunnel. If string 1 here is start or it's blank, then, okay, I have to look at this one a little bit backwards here. Okay, look down here at the end. We've got a while, do, done, right? Again, a standard sort of programming structure of a loop. We've got the while condition, do the commands until we are done, and then loop back, reevaluate the condition, do these commands again, and again. Okay. This is a command, we've talked about ls before. It's the one that lists the files in a particular directory. Okay? -1 means in a single column. Okay? And this says the path and everything that ends in .server.conf. This little weirdness we'll talk about later, but essentially this says dump all errors to dev null, no place, okay? And then use the output of this command as the input of this command, okay? So this ls-1 generates the output of a list in a single column, and this read line reads each line of a list. So basically what we have here is what in other programming languages we would have as a for each loop, right? For each, and then an implied item in the list, okay? Do the instructions, loop back until we get to the end of the list, and when we get to the end of the list, go on to the next thing. And in this case, the next thing is exactly the same, except it's all the files that say client.conf, okay? And then it goes on and does its magic here, and then it's done. And then it's the end of the if statement, okay? This if statement is never going to be true if this if statement was, okay? And so it will reach the end of the file and return to the calling program. Okay, so let's experiment with this ls-1 for a minute, because it's a really interesting it's a really interesting trick that somebody pulled when they were writing the ls command, writing the code for the ls command. So let me clear the screen here. Okay, I'm going to change to the directory cd etc stunnel. No, wait, I'm not going to do that. I'm going to do it this way. I'm going to say ls-1 etc. That's the same way it's headed in the script. I want to try it almost exactly. ls-1 etc stunnel. Okay, so if I say ls-1 etc stunnel, what do I get?
A list.
I got a list of just plain file names. Now what? If I do ls-1 etc stunnel star.conf, what do I get? I get the paths tacked onto the front. Yeah? So, the inconsistency of the output fooled whoever wrote this script into believing that it was necessary to put etc stunnel before the name of the file, okay, when actually, like www.client.conf, server.conf, okay, when actually string line is already going to have the path on it. So, all we need to do is, hey, and we can see this in action again. We do this. Okay? If we look up here, and it says starting stunnel with, okay, in the shell script, let me see if I can do this upside down. I'm not sure if I can. That's not working. Okay, here it says echo, print on the screen, starting stunnel with the value of the line variable, and that's the same one we use here, right? So, starting stunnel with, when I look at the command, it's right here. It's got the whole path perfectly, okay? So, what I need to do is edit my shell script and just delete this part. So it says string line, just like the one above it does, because we can see that it is correct when we did our testing. So I'm going to F2 that one, save it, go back over here, test it. There we go. Error. Oh, now what's this error? Error resolving ldap.tinynet.edu. Neither node name nor server name is known. Is that a problem?
No, because so you need to open the activity, right?
That's right. I know I didn't have, I know that my LDAP server is not running. So that's actually not only not a problem, it is a very good sign, okay? Because it means it's going to try. And when my LDAP server is running and has registered with DNS mask on the gateway, it's going to be able to find it. So, very good, all good, okay? All I need to do now is do that on the mail host and the gateway, and I'll have my base system ready to rock and roll. Where am I at here? Let's just rc.d, jump down to the bottom, Ooh. RC.S tunnel. Let's do the permissions first. 9 F H. Set the execute bits. And then we edit it. F4. And back out the unnecessary text. Save and exit. And do the same thing on the gateway here, because I want it running on the gateway 2. Alt F2. Let's just move over here and do it on this side. And where am I at? Can't see. There we go. Okay, as I was doing that, I realized that there was one more thing that we were supposed to check and we forgot to do it. Okay, and that was back you. What are you doing here? Oops, sorry. That was this one. Okay, we looked at this up here and we forgot to do it. Okay? Anyone who can read the PEM file can compromise your SSL security. The PEM file must be readable only by root or the system account that runs S-Tunnel. Ouch, man, how did we forget that? Never mind, just a quick check. Just jump over here. Which one is this? That's my mail server. Fine. And etc. And S-Tunnel, what do I need to do? Find the PEM file and F9 and file. And there we go. chmod. Uh-oh. Read by owner, write by owner. Read by, who's the owner?
Root.
Root. Root, that's fine. But I better turn this one off. It's gonna change that last 4 to what?
640, right? So
Yep, 640. Okay, that was simple enough. Done on the mail server. RC.S-Tunnel. Let's just back up on this one. S-Tunnel. F9. File. Hmod. Ouch. Turn that off. And on the web server, how do I get to see the web server? Which one? Here's my web server. All done with this. That's F10, this one. And, I'm still right there. Oh, nice. F9, F, file, H, Okay, these yellow, just one more thing in MC, okay? You see that F in file, or the C for command, the O for options. You can use those letter keys as a shortcut, okay? So if I get out of this and I say F9, all I have to do is F for file, and then I do H for chmod, and then as always, set the permission or turn it off with spacebar. And I'm ready to go.
We are doing this for gateway, web host, and mail host, right?
Yep, you need to do it for all three. It's just one of the things about running a whole network is that you have to get the network configured consistently on all of its hosts. And so sometimes you end up duplicating your effort a little bit. But that's also a good sign because it gives you a little bit more practice. Okay? And practice helps us remember. Okay, now we're not really going to, there's not going to be any visible difference in the way things run using SSH or not. So I'm not going to go through any kind of tests or anything for this, okay? We're going to leave this as it is, and I'm going to encourage you to find ways to look at it and find ways to test it, adapt it, okay, break it as we move on, because this is the end point of the first part of what we wanted to do. This is the base system. You've got this system up and running, then that's 35% of the assignment mark in this class, okay? If you don't have this up and running, okay, or if you're still having a few residual problems, in my course is AHSSN. Okay. 1704. Okay. In the intake specific folder, not up at the top, but down here in the intake specific folder, okay, there is a little text file here that lists out all the actual changes that we made while we were exploring all of these other things. Okay, so if you need a quick start or a quick restart, just check this text file and it's there for you. Okay, and right alongside it is the assignment. Okay, so you need to start thinking about partners, groups for the assignment. You need to start thinking about tasks that you want to take on. Okay, again, the ones that are there are suggested. Okay, it's not a complete and exhaustive list. View page width. Okay. And again, oops. Feel free to use your imagination when you look at these, because I'll be happy to help you evaluate your idea to see if it's, just to say if I think it's actually going to be possible to get done or not, and we'll put a point value on it, okay? Any combination works, okay? Partial implementations, except maybe for the 5.1s. 5.1s should be straightforward enough because there's plenty of documentation and some step-by-step guidance in the configuration files for those, okay? But otherwise, if it works, or if it almost works, and you've documented why you had to stop and move on to something else, that's great for partial credit for the enhancements, okay? As it says here, the lower point values are more straightforward and more easily available resources. The higher point values get fuzzier, or there's more documentation that you have to read, or there's too much inaccurate documentation, okay? Or you might have to, do what you can to do them. But they are all possible. They have all been done in the past. Okay? And again, I think, especially for this class, a lot of you have used a Kali Linux virtual machine in the past, right? And you can set up a Kali Linux virtual machine in VirtualBox. It's extremely simple. You just have to use, I think, as I remember, the Kali Linux comes in VDMK, right? The VMware hard disk format. But all you have to do is choose a VDMK when you set up the virtual machine and you attach the initial storage. Okay? Other than that, that's all you need to do to create it, give it enough RAM, and you can use it. Okay? The limitation is going to be the physical memory in your computer. Okay? I strongly recommend, if you've only got 2 gigabytes physical RAM in your computer, skip the Ubuntu stuff, because Ubuntu feels very cramped and close-quartered in less than 2 gigabytes of RAM to itself, especially, Ubuntu with the GUI, I think it actually, for me, it actually cannot run in a virtual machine with less than 2 gigabytes of RAM. Okay? You get unacceptable performance, you get too much swapping, you get weird errors. Okay? So don't try it in a machine with less than 4 gigs RAM. If you can find one with 4 gigs, 8 gigs, more, go for it. Yeah? One of the things that we're going to cover very well, as immediately as we can, I think what I want to do is, when we get back from the semester break, I want to do the user management and GCC compilation from the TinyNet site, okay? We'll spend 1 week, maybe 2 on that, and then we're going to move in this HSSN immediately to NetR, okay? What on the TinyNet site. Oh. Is this one, Breaking Bad. Oops. And that R. Okay. We're gonna jump up to this one, 8 here, especially for the ASCII art part. And then, as quickly as possible, we're gonna skip down here to Breaking Bad and net R. Okay? Because everyone in here is in security and forensics, and next semester you're going to be doing ethical hacking, okay? And NetR is specially made for that because NetR is using a TinyNet to make a corporate network that you can use for penetration testing, you can use for ethical and unethical hacking, you can attack it and tear it apart as much as your conscience will allow you, because you have to fix it when you break it, okay? So I want to encourage you to think about using the assignment for this class to prepare for the next class. Get some leverage, okay? Get a little bit of a head start, okay? And go through and follow the instructions to get this NetR to migrate. Get your LDAP server set up, and then migrate your TinyNet servers over to NetR, so you have a network that's using SSL to communicate between its servers. It's divided up on a few subnets, okay, so that you can attack it with your Kali Linux tools, Metasploit, and things like that, okay? We've got EtherCap set up here, and we'll look at EtherCap because we've got a TinyNet implementation of EtherCap, and you can use that as well, okay, to set up your man-in-the-middle attacks, to do a little bit of basic packet sniffing, okay? But, you know, the reality is the GUI-based tools are nicer in some ways, and we don't want to do ethical hacking with anything that's connected to a corporate network or a public network. Really, keep it on an isolated subnet, and this is a great way to do that. Okay? So, take a look at it, think about it. It mentions NetR in the assignment. It wasn't there, it's not part of the main part because it wasn't ready when the main part had to go off to SU for approval. Okay, so I put it on there as an additional part. They approved the fact that I could add additional parts, so all good, right?
I look at the end of the assignment, I realize that there is a part for man-in-the-middle attack and pen testing for our TinyNet.
Yep.
Are we limited to NCAP and EtherCap or ETC?
Again, no limits.
So meaning if I want to use SET, I'm allowed to do
If you want to use what?
social engineering kit.
Social engineering toolkit? Yeah, I'm in. It's fine, yeah. But again, the only reason I have EtherCap and Nmap and what do I say? Netcat, okay, is because I found the source code and I compiled them for the TinyNet kernel version, and they work fine there. And a lot of the tools, other tools, especially the Kali Linux tools, they take a Python interpreter, and the Python interpreter is way too fat for what we want to do with a TinyNet. Yeah? And so if you want to do Metasploit or SET, that stuff is all Python. It is. And so use your Kali Linux virtual machine. Just get a computer with enough physical resources. Far away.
So this assignment is 100% in course or?
No, this class is 30% exam. Okay? And so we're going to have some exam review sessions that are going to be worked into the schedule down at the end of the semester, kind of exam cram stuff. Okay? There are sample review questions here already. Take a look at them. The questions are in one file, the answers are in another file, just to encourage you to think about it a little bit. Okay? But they're all very common things that mean that if you do well on this exam, you've got the kind of prerequisite knowledge that people are going to assume that you have already when you move on and start working in Linux environments and systems administration. Yeah? They're all about the kind of prerequisite knowledge, stuff that comes in handy to know as you move on. Okay? So again, we'll get started on it. Have a nice semester break. Don't crack your heads over this too much, but think about it a bit, and we'll get serious about it in 2 weeks' time.
Sir,
Yeah.
have you decided the exact date of our submission?
No,
Okay.
I need to look at the calendar. Look at that. That to me is getting serious about this, and so
That's alright. Good.
let's do that. Let's do that in 2 weeks' time.
Okay.
Yep. Yep. Come back. Next week is a break. So when we come back after that, yeah, then we'll sit down and go through the dates and look at the time we have and
Okay.
see how to move things forward. Okay.
他跑 TTC 这个 TTC accident 他跑到一个什么报是吧？好像是完成了，没有什么重要。他跟铁船还有龙马，那个哇，其他三个有电话比较只是另外一个。Then you go do it not? You go do it not? Then you have no access. 有做没有？喂。因为他讲3个都要用，可是他没有做，你有做没？